Hey guys, welcome to Unit 9, Lesson 6. We're going to get started with the warm-up. I highly recommend pausing the video and try the warm-up on your own and see your answers or match your answers with mine. We're not using the calculator, so you're going to be doing no calculator please for this lesson again. So let's get started with the question. A point moves along the x-axis so that its position x at time t is specified by the function x of t equals t cubed minus 9t minus 9. Determine the following. So part A says the time intervals on which the point is moving to the right and to the left. Again, if I look at my equation, I have been given a position equation, and if I'm moving to the right or left, I always talk in terms of velocity. My velocity is greater than 0 and my velocity is less than 0. Since velocity is not given to us, we need an equation for velocity because I've been given an equation for position. So how do I determine my velocity equation? Velocity is the first derivative of my position, so my velocity will be 3t squared minus 9, and that's what it is. I'm going to set this equal to 0, and then I'm going to solve for t. So I will get 3t squared minus 3 equals 0. I can get rid of the 3. I'm left with t squared equals 3, and t is equal to square root of 3. Usually I'll do plus and minus, but I'm going to ignore the negative because we don't deal with negative time. So here I'm going to draw my number line. I'm going to cap it at 0, right? And my other important number is rad 3 on that number line. So now I'm going to pick a number from each interval and determine if it's positive, then it means it's moving to the right, and if it's negative, it's moving to the left. So rad 3 is 1 point something, so between 0 and rad 3 I can pick 1, and since this is a velocity number line, I'm going to write that here so we know this. I'm going to substitute in my velocity equation. So if I substitute 1 into my velocity equation, I get a negative number. So it's negative here, and if I substitute a number greater than rad 3, I'll say, let's say 2. If I substitute 2 in here, I do get a number. I get positive here. So it is moving to the right over what interval? We need to write the interval. Right is where it's positive from rad 3 to all the way to infinity, and left it is from 0 to rad 3, right? So part B, it says the time intervals on which the point has positive and negative acceleration. Again, we need to talk about our relationships. What is the relationship of acceleration to our given equation? So here I know my acceleration is the derivative of velocity, so I'm going to find my a of t, which would be what? Derivative of 3t squared is 6t, and negative 9 goes away. I'm going to set it equal to 0. So 6t is equal to 0, so therefore t is equal to what? 0. So here my number line, this is interesting. My acceleration number line is what? A of t, and the only number, I'm going to start at 0, and there's no number that I'm going to put on the line because t is equal to 0. So it's either going to be, so acceleration is going to be either positive or negative for the entire time. So let's pick a number, any number you can pick. So let's pick 1. So if I substitute 1, I get a positive number. So basically my acceleration is going to be positive from 0 to infinity, and it's never negative. Right? Part C, the time intervals when the particle is speeding up, slowing down. This is when we compare our number lines, when we compare our velocity and acceleration. So I'm going to actually sketch them here so that it's easier to compare. And this was 0, rad 3, negative, positive. I already have from part A and B. That's where I'm copying it from. And I'm going to exactly do the same. And this was what? Positive all the time. So speeding up from 0 to rad3. It's speeding up when they both have the same signs. I'm going to still say velocity and acceleration have same signs. Slowing down, velocity and acceleration have opposite signs, right? So we're comparing here. So now let's go to our number line. So if you compare from 0 to rad3, they have opposite signs. So means it's what? Slowing down. So it's slowing down from 0 to rad3. And it's speeding up, because if I look at after rad3, it's positive and acceleration is positive all along. So it is speeding up from rad3 all the way to infinity. Okay. Part D, the acceleration at times when the velocity is 0. So here, if I look at part A, when my velocity was set equal to 0, what do I get? T equals rad3 from up above, right? From part A. So I want to find my acceleration at this value. That's what it's saying. When velocity was 0. So A of rad3 from my part B, I know A of t is 60. So it'll be what? 6 rad3. Part E. The average velocity over the interval 0, 6. From 0 to 6. Okay, so this can be, you have to be very careful about this. This can be confusing at times because students are often confused that it's asking me for the average velocity. So am I going to use x of b minus x of a over b minus a, or I'm going to be using v of b minus v of a over b minus a? So think about it. Average velocity is the rate or slope of the position function. So I'm going to be using this, my position equation that's been given to me in the original, and find the average velocity for that. Okay, so this is something students often confuse themselves with. So I just wanted to bring it up. So I'm going to be doing is x of 6 minus x of 0 over 6 minus 0, which is x of 6 is 153 minus negative 9 over 6. I have 162 over 6, which is 27. So we are actually trying to calculate the rate or the slope of the position function. So that's your warm-up. Let's get started with our lesson. So sometimes we aren't given an equation or a graph, but rather a table of discrete values. In these cases, we are at the mercy of the limited information given to us. In the table, we don't know every single value for the given function or the given particle, I would say here. So we need to make the most out of it and know how to read these tables. So the first one says the values of the coordinate s of a particle moving smoothly and continuously along a line for various values of t are given below. So first of all, you must know what table you're given. So here you're given the position, right? It says s, so this is your position table. So part A says what is the displacement of the particle during the given 4-second interval. So basically, I'm going to use my formula, which is what? S of b from displacement is what? Difference between from where you ended and from where you started, right? So S of b minus S of a, so which is what? S of 4 minus S of 0, which is 0.2. S of 4 is 0.2 minus 40, which is negative 39.8. right? And this means what? We're going to the left 39.8 feet, right? The negative, it's not asking us for an explanation, but we should be able to analyze this. Okay, Part B. How many times does the particle change direction and t belongs to, that symbol means belongs to, between 0 and 4 seconds justify? So again, going back to your definition, that's your justification. When does it change direction? When velocity changes signs or goes from positive to negative, right? Let's write changes signs. So how to get velocity from a position table? Remember, velocity is the derivative of the position. So we can find this derivative, but we definitely can look into the slopes, and where slopes means where the position is increasing or decreasing. So over that interval so let's look at the table. So if you look at your y values, right, what's happening? From 0 to 1, it's decreasing. So I'm going to just go put a negative here, right? Do you see the slope is increasing? If you were to plot these points, your 40 to 35 to 30, the values are decreasing. Means what? Your velocity is decreasing. Now, if you look from 1.5 all the way to 2, or 1, yes, it is increasing. Do you see? So this is going to be a positive slope, or my velocity. I'm going to say velocity is negative, velocity is positive. And then 45, 38, 16.2, these values are y values are decreasing. So I can say velocity is negative over that interval. So how many places did it change sign? It changed sign at 2 places. It went from negative to positive and then positive to negative. So it's asking me how many times? It's 2 times. What is the particle's average velocity? Again, average velocity from 0 to 0.5 seconds. So basically, we're finding the slope from 0 to 0.5, which is what? S of 0.5 minus S of 0 over 0.5 minus 0, which is what? 35 minus 40 over 0.5, which is negative 5 over 0.5, which is negative 10. This is average velocity, so it's going to be feet per second. Going back to your y-axis unit over x-axis unit. Okay, I just want to talk more about this. Estimate the velocity at each of the following. So basically, we are estimating the velocity using the position is basically saying find the average rate of change or the slope, right? So which would be, so there are multiple ways actually you can find it here. So since 0, I'm going to just zoom in a little so we can see the table also. Okay, so here, if you look at my 0.5, I can do the slope between 0 and 0.5. Or I can do between 0.5 and 1, or I can even do it between 0 and 1. So any of those 3 answers will be acceptable. I'm just going to try to do it from 0.5 minus S of 0 over 0.5 minus 0, which is what? Negative 10 feet per second. Okay, so now part 2. 2.7. Again, if you look at 2.7, there are 2 ways you can do it. So you can either do from 2 to 2.7, or 2.7 to 3, or you can even do from 2 to 3, right? I don't want to deal with decimals, so I'm going to actually do from S of 3 minus S of 2 over 2.7. Oh, no. I had to do 3 minus 2. My bad. 3 minus 2, which is just 1. So it's going to be 38.2 minus 48.2 over 1, which is what? Negative 10 feet per second. If you were to use any other interval, you will end up getting a different answer. Like if I said I did from 2.7 to 2, I would have ended up with a different answer, and that's okay. Both these answers will be acceptable. So you don't have to worry about, oh, my 2 answers are different. It does not matter. Okay. Part 3. at t equals 3.5 seconds. So let's look at the table up above. I just want to talk about this. So 3.5 is actually between 3 and 3.6. So there's only one way you can do this question, right? 3.5 is not in the table. So only one interval that which will be accepted, which is what? S of 3.6 and S of 3.6 minus S of 3 over 3.6 minus 3, which is 16 minus 38.2. I like to avoid decimals whenever I can. So, which is 22.2 over 0.6. And you can leave it, since we're not using the calculator, you can leave your answer like that, and that's okay. You don't have to simplify it. So, finish up the remaining lesson, guys. If you have any questions, reach